You know, when we think about AI, it feels like the race has always been about one thing, going bigger. Just building these massive models. But what if that's not the whole story? What if the real secret to making AI smarter isn't about building one giant brain, but about creating a whole team of them?
So the question we've all kind of been asking is, to get smarter AI, do we just keep throwing more power at it? Just build bigger and bigger digital brains? Well, some really interesting new research is suggesting the answer might actually be no. And the alternative they've come up with is pretty mind-blowing. Let's get into it.
Okay, so first things first, we gotta understand what's wrong with the way we're doing things right now. Let's call it the giant AI problem.
So the current approach, the main strategy, is to build what they call a monolithic model. Just think of it like trying to build one single giant skyscraper that does everything. One massive, all-powerful AI, something like a GPT-5, that's supposed to be a jack-of-all-trades and solve literally any problem you can think of.
I mean, that sounds pretty impressive, right? But this whole bigger is better idea, well, it's starting to show some pretty serious cracks.
And here's the deal with these giant AIs. For one, they're just incredibly expensive to run. They can also be pretty slow and inefficient. But maybe the weirdest part? They can develop some really surprising biases. Kind of like they're picking a favorite.
And get this is that bias in action. When a huge model like GPT-5 needs to hand off a task, look what it does. It calls its own family member, this GPT-5 Mini, a whopping 73% of the time. It's basically just choosing its own team, even when another tool might be better, or faster, or way cheaper for that specific job.
Okay, so that's the problem. But this is where a team from Nvidia comes in with a totally different idea. A pretty radical one, actually. Let's call it the orchestra conductor idea. And their whole philosophy is summed up perfectly right here. The idea is that true intelligence doesn't come from one giant monolithic thing. Nope. It emerges when you get a whole system of specialized parts all working together. So what they built is something called an orchestrator. Now, this is not another giant brain that knows everything. Instead, think of it as a smaller, super efficient manager AI. Its entire job is just to direct traffic, to figure out the best tool or the best specialist AI for each little part of a problem. It's basically a project manager for other AIs. And this is the perfect way to think about it. The orchestrator is the conductor. It's not trying to play the violin or the drums itself. No way. Its job is to know the strengths of every single musician in the orchestra, or in this case, every single AI tool, and tell them exactly when to play their part. The result? A perfect symphony, or, the right answer to a complex problem.
So you might be wondering, how in the world do you teach an AI to be a good conductor? I mean, you can't just hand it a book on management, right? Well, the way they do it is actually pretty clever.
They use something called reinforcement learning, but let's just cut through the jargon. It's basically like training a dog. Every time the AI conductor makes a good call, it gets a reward, a little virtual treat. Make a good decision, get a treat. It's that simple. And that reinforces the good behavior.
So what exactly is a good job for this AI? Well, the rewards are based on three main things. Number one, obviously, did it get the right answer? Number two, was it fast and efficient? And number three, was it cheap to run? To get the biggest reward, it has to nail all three.
See, it's not just about being correct. The whole system is being trained to find the sweet spot, the solution that is both right and cheap. And that's a balance that those giant one-size-fits-all models really struggle with.
All right, so the theory sounds amazing, right? A smart conductor leading a team, but does it actually work in practice? Let's take a look at the numbers because, wow, they're pretty staggering.
Okay, so they put this thing to the test on a benchmark that's designed to be super difficult. The little orchestrator model, and we're talking about an 8 billion parameter model. Think of parameters as just brain cells, basically. It actually scored higher than the massive GPT-5. The small, scrappy team with a smart conductor literally beat the giant.
And this wasn't some one-off fluke. Look at this. Across a bunch of different, really complex tests, for reasoning, for following tricky instructions, the orchestrator system just consistently beats the much bigger, much more expensive GPT-5. It's not just a little bit better on one test, it's proving to be smarter across the board.
But being smarter is only half the story. It's also about being way more efficient. We're talking about using way less computing power to get the job done.
In fact, this whole orchestrator system is 2.5 times more efficient than just throwing a giant model at the problem.
And of course, that efficiency translates directly into saving money. A typical question costs just over 9 cents using the orchestrator. That same question on GPT-5? Over 30 cents. We're talking more than 3 times cheaper. In the world of AI, that is a massive deal.
So what does this all mean for the future of AI? Well, it really feels like we're looking at a fundamental shift in how we think about building these things.
The big takeaway here is pretty clear. The future of AI isn't just about size. It's not about building one single, ever-growing brain. The real game changer is smart collaboration, figuring out how to make smaller, specialized AIs work together like a well-oiled machine. And why should you care? Well, for one, it means we can build even more powerful AI by just being smarter about how we combine the pieces we already have. It also makes this advanced technology way cheaper and more accessible for everyone, not just a handful of giant companies. And really, at the end of the day, this isn't just some new technique, it's a whole new philosophy for building intelligent systems.
And all this leaves us with a really fascinating question to chew on. We've already seen what a single AI genius can do, and it's pretty amazing. But just imagine, if this new approach lets us build not one genius, but an entire team of them, all working in perfect harmony, what kind of problems could they solve then? What challenges could we overcome that a single mind, no matter how big, could never even begin to tackle on its own?